Okay, so turn to page 38, please. And what we're going to talk about are some of the bonds, and then our covalent molecular structures. And if we think about maybe, we go with a simple one, and you've done this one already, and I'm just going to draw the bonds then. This is obviously a covalent molecular structure. It's made up of non-metals, and it's also a molecule. Okay, it's a discrete particle. We're not going to see molecules of our non-metals or ionic compounds. But what happens if there's another one? And remember that when we were talking about the properties of molecules or covalent molecular substances, we said they were frequently gases, liquids, and soft solids. And what that is meaning is that there isn't much attraction between them. So this molecule is not really very attracted to that molecule. And if there's low attraction, you'll end up with a gas. If there's some bit more attraction, then you'll end up with a liquid or a solid. But by and large, they have very low attraction. Okay? So this we call, it's a weak force of attraction. If it was a strong force of attraction, these molecules would stick together and it would be really hard to break them apart. But if they're gases and liquids, then that can't be the case. Yep.
Is that because they've reached noble gas configuration and they have no charge?
Yeah, yep. Yeah, all of those electrons are fixed in those bonds already. There's no net charge, and so they're not attracted to each other.
If there's no net charge at all, how is there any force of attraction between them?
Okay. Now I'm just going to give this a particular name before we go on. If when you travel interstate, where do you go? No, well, yeah, but where do you end up? In another state.
Right.
Yeah?
Yeah.
Interstate travel, you end up in another state. So, intermolecular force of attraction, you end up at another molecule. Okay? So we have to learn this word, that it's an intermolecular force that's weak because it's between the molecules. I'm going from one molecule to another and it's a weak force. Because if we look at this here, this bond here, this is a strong force of attraction. And if this is intermolecular, what do you think the other one is?
Another one.
Well, if I'm calling this inter, what's another way of, what's a way of saying inside? Intra. So just like if you have an intravenous injection, it's an injection in the vein. Yeah? So it's inside. And this is inside the molecule. So it's intramolecular force of attraction. This is why it's a gas or liquid or soft solid. And this is what holds the atoms together, the bonds within the molecule. And we know that those are strong bonds of attraction because we need to achieve that noble gas stability. which they get by sharing those valence electrons. Now, back to Jarek's question, how can there be any force of attraction at all then? Well, if we haven't really looked too much at water yet. But I think I have mentioned to you that oxygen is greedy, if you like. It's electronegative. It takes more than its fair share of the electrons from the bond with the hydrogen. And that even though there's no net charge, okay, the charge overall is 0, the ends of the molecule are polar. And so there is weak attractions between them. This is why water is a liquid at room temperature. And the other reasoning would be, and this is something that you would get to if we go into chemistry 4, is that I'm just going to represent these as long molecules, very long molecules. We have lots of positions along there where they can interact with something that's known like a temporary dipole is what it is. Yep.
So with the first example that you gave, does carbon also remove that electron closer to itself and then hydrogen becomes slightly negative, or is
Hydrogen
that why
can
there's
only, no, it will be positive, but in actual fact the electronegativity of carbon and hydrogen is very similar. And so it's almost an even sharing of the bond, but because of the symmetry, it's all even all around. You know, from outside, it's even sharing. So there's very little attraction. This is methane. This is the gas that it's called natural gas if we use it, and that's what we have in our Bunsen's in the chemistry lab. Okay, so this is really important that you know the difference between inter and intramolecular forces of attractions between the molecules. So I'll get you to read the information there on page 38. And James seems to have come to visit us, so I'll just turn this off and...
Sorry to interrupt, Steve.